Hello, good morning, everyone.
Good morning, sir.
Okay, so what was the last topic in physics? Yes,
Factor affecting resistivity.
factors affecting resistivity means we have done resistance, right?
Yes, sir.
Okay, so now we can discuss combination of resistors. Combination of resistors. How many combinations are there? If we are having certain number of resistors, we can arrange them in series combination or parallel combination or mixed combination. Mixed combination means some of the resistors will be in series combination and some of them will be in parallel. Now we have to find out resistance for these parallel and series resistors. So let us consider first series combination of resistors. Series combination of resistors. What are the key factors in series combination or key points in series combination? First point is that all the resistors will be in a single wire. So in series combination, only one wire will be used. This single wire may be a straight wire or it may be a curved wire, but all the resistors will be in single wire. Second important point in series combination is that because we are having a single wire, so current will be same throughout the wire. And all the resistors are connected in a single wire, which implies that all resistors will have same current. So same value of current in all the resistors will be there in series combination. But there will be different potential for different resistors. Different potential for different resistors. And one more property in series combination, it can be proved that resultant resultant resistance or equivalent resistance or net resistance of a system in series combination will always be greater than individual resistance. Individual resistance. individual resistance. Understood or any doubt?
No, sir.
This this is the series combination, and in series combination, if we have, let's say, n resistors with different values of resistance, and they all are connected in a single wire. Let's say this is R1, this is R2, this is R3, and this is Rn, and this terminal is positive, this terminal is negative. So in this case, net resistance or equivalent resistance Rs will be R1 plus R2 plus R3 plus dash dash dash. Understood?
Yes, sir.
Now, next combination is parallel combination. First point about parallel combination is in parallel combination, all the resistors will not be in a single wire. There will be different wire connecting to a terminal point for different resistors. For example, let's say this is a wire, and then here we have a joint, and at this joint there are different wires in which different resistors are connected. Resistor R1, resistor R2, and resistor R3, and so on. And another terminal will also be common for all the wires. So in parallel combination, different resistors have different wire, but their connections will be to the same terminals or same end points. Let's say this is A and this is B. This is first condition to check whether the combination is parallel or not. So if you are having a single wire and then at any joint or at any point of the wire, there are coming out more than one wire, and then they will also be connected to the other end or other terminal of the circuit. Important point in parallel combination is that there will be same value of potential for all the wires. So same value of V for all the resistors. But there will be different value for electric current. Different value of electric current I for different resistors. Potential will be same. Fourth point is, if you will calculate the net resistance or resultant resistance in parallel combination Rp, it will be always less than individual resistors. Individual resistance. So it will be less than R1 is it will be less than R2 and so on. It will be less than all the resistors which we are using in the parallel combination. Formula for parallel combination, we have 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. There will be a special case for two resistors which will be frequently used. Special case if we have only two resistors combination R1 and R2. In that case, 1 upon Rp is equals to 1 upon R1 plus 1 upon R2. And on simplification, the result will be multiply of both the resistors divided by sum of both the resistors. So this will be the formula for Rp if we have two resistors in parallel combination. Third case is mixed combination. In that combination, there will be few resistors in series and few resistors in parallel, and we have to find out the net resistance of the system. To calculate the net resistance of the system, we will calculate it in two different parts. We will solve the system for series combination separately and parallel combination separately, and then finally we will rearrange the circuit or system of the resistors. Let's take some few examples. This is resistor with resistance 2 ohm. This is with 5 ohm. And here we have 10 volt DC current. You have to find out in this figure, find number one, net resistance, number two, electric current I in R1 and R2 both, and three, potential V4 R1 and R2. This is the question. So how will you solve it? First point is we have to find out equivalent resistance or net resistance, which is very easy to solve in this circuit, because we are having a terminal of battery here and another terminal here. So you will look at this terminal, there is a wire, and in this single wire both the resistors are connected, which means this will be a series combination. And in series combination we can use RS, that is R1 plus R2 directly. So RS will be, let me do it 3 ohm, so that calculation will be easy. So RS will be how much? 2 ohm plus 3 ohm, that is 5 ohm. So overall resistance of the system is 5 ohm, net resistance of the system is 5 ohm. So first answer will be R equivalent equals to 5 ohm. Now we can work on second, in which we have to find out current I in resistor R1 and R2. This is the property of series system. Bhai, this is the property of resistors in series combination, that there will be the same current throughout the wire. So it implies that the current I in overall circuit will be same as current I in 2 ohm resistor and current I in 3 ohm resistor. So what will we do is that we will find the current for overall circuit. And in that case, we have overall voltage 10 and we have overall resistance or net resistance, that is 5 ohm. And we can simply apply V is equals to IR. V is equals to IR will give us the value of current. This is 10, this is I, and this is 5. We have to find out the value of I. This will be, I think, 2 ampere. So current I in resistor R1 will be same as current I in resistor R2 will be same as current I in the circuit. Or let me write it as current I in series system. And the answer will be 2 ampere. Third part of the question is about what will be the potential for R1 and R2. Now we know that value of R1 is 2 ohm and current I for R1 resistor is 2 ampere. We have to find out V. Again, from this information, we can use V equals to IR, which will be 2 into 2, that will give us 4 volt. So there will be 4 volt. 4 volt. We have total 10 volt and 4 volt is utilized for 2 ohm resistor. So remaining 6 volt will be for 3 ohm resistor. Or you can also look at it, the value of R2 is 3 ohm, current in R2 is 2 ampere. We have to find out again using the relation V equals to IR. We can say that 3 into 2, this will again be 6 ohm. Understood or any doubt?
Understood, sir.
Okay.
No doubt, sir.
Next, combination of resistor is in parallel, let's say. So there is a combination of three resistors in parallel. This is connected to, let's say, 10 volt, and resistance of each resistor is, let's say, 3 ohm. You have to find for the given figure, number one, equivalent resistance of the system, number two, potential V, and number three, current I. So first of all, we will work on net resistance. So in this case, we have parallel combination clearly, because from terminal point A, there are different wires which are coming out, and then finally these all wires are going to point P. So this type of arrangement is parallel combination. And in parallel combination, we have R equivalent. We can calculate R equivalent using 1 upon Rp is 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon Rp will be 1 by 3 plus 1 by 3 plus 1 by 3. कुछ फायदा हो रहा है तुम्हारा, सुबह ही आके इधर बैठेगा, ये ध्यान दे लो। इतना डिफिकल्ट भी नहीं है कि नहीं समझता, फास्ट जाता। 10th का कॉन्सेप्ट है ये, ध्यान दोगे नहीं तो समझेगा कैसे। 1 upon Rp is 1 by 3 plus 1 by 3 plus 1 by 3 will be 3 by 3, which is 1. So net resistance in this combination will be 1 ohm. So R equivalent is 1 ohm. And now we can work on second part of the question, which is about the potential. And again, this is a special property of parallel combination resistors. If we have certain resistors in parallel combination, potential will be same for all the resistors, and this potential will be equal to the overall potential of the system. So in this case, overall potential of the circuit is 10 volt, which means this resistor will also have 10 volt, this resistor will also have 10 volt, and this resistor will also have 10 volt. Understood? So potential for R1 resistor is same as potential for R2 resistor, and it's same as potential for R3 resistors. Apart from this, this potential will be same as overall system, which is given to us 10 volt. So value of potential difference at R1, R2, R3 will be 10 volt. Now we can work on third question, which is about electric current in these resistors. So for R1, we have the value of R1 3 ohm, and we have potential for R1 10 volt. And we want to have current I. So we can use relation V equals to IR, which indicates I will be V by R. V is 10, R is 3. So current I will be 10 by 3 ampere. Now, if you will look at the system, it is symmetric. All the three resistors are equal, and voltage for all the three resistors is also same, which means they will have same amount of current. So if you will look it in a different way, let's say find out total current in the circuit. What is the total current in circuit? Total current in circuit. So for total current in the circuit, we have to find out total resistance of the circuit, R equivalent, that is 1 ohm. Overall potential for the circuit, that is 10 volt, I think. Yes. And we have to find out overall current. So V is equals to IR will give us the value of I, that is V by R, which will be 10 by 1, that is 10 ampere. Which means from this terminal of battery, we will have 10 ampere current. And from this terminal of battery to point A, there is a conducting wire, and at any point of the wire, the value of current will be same. At point P, point Q, point R, at all these points, the value of the current will be same, 10 ampere. Because this is conducting wire means there is no resistance in the wire. So from this point to this point, there will be 10 ampere current. Now at point A, there is 10 ampere current, and from point A, there are three different wires. So here will be distribution of the current, and current will go in different branch with different values. Let's say here it will go with I1 value, with I2 value, with I3 value. But this question is a simple question, and in this question we direct have symmetry in all the component of the circuit. So this and this, all these resistors are same with same potential, which indicates that amount of current will be same in all the three branches, which clearly states that if we have total current 10 ampere at point A and it is equally distributed on in three branches, one branch will have 10 by 3 ampere. 10 by 3 ampere. So you can also say that current in resistor R1 will be 10 by 3, and this will be for R2 and this will be for R3. Total current is also given by I1 plus I2 plus I3, which will again give us the same value. That will be 3 times 10 by 3. 3 factor will cancel out, and we will have again 10 ampere. So there are different ways to calculate current and potential in a circuit. It will all depend on the question. Understood or any doubt?
Yes, sir.
Understood, sir.
Okay, next point is, which is a very important result for electric wire. First point is, if I have a wire of certain length, let's say I have a wire of certain length L, and this wire is cutted into two pieces. One piece with length L1 and another piece with length L2. If the resistivity of this wire is rho, what will be the resistivity of wire with length L1 and wire with length L2? Yes. What will be the answer? Anyone? If I have a wire of length L with resistivity rho, and then I cut it into two pieces or more than two pieces with different length L1 and L2. Now the question is, what will be resistivity for wire with length L1 and L2? Anyone? 10th level का क्वेश्चन है, पता होना चाहिए आप लोगों को.
Rho by 2, sir.
How much? No one. कोई आंसर नहीं दे रहा. Very good. Okay. Important point about resistivity is that resistivity is the characteristic property of a material and it does not depend on dimension. I have already told you this. It is independent of dimension. If it is independent of dimension, it doesn't matter what is the length of wire or what is the cross-sectional area of the wire. Resistivity of the wire will be same until we change the material of the wire. So if I have a wire with silver material and I cut it into two pieces or more than two pieces, there will be no change in resistivity. Resistivity of silver material will still be same. So resistivity of wire with length L1 will be same as original resistivity, and same is true for wire with length L2. Understood or any doubt?
No,
Second
Understood,
point.
sir.
Okay, second point will be like this. We have a wire and with length L, let's say, then this wire is stretched. This time we are not cutting it. We are stretching it in such a way that the length of the wire is doubled. What will be the resistivity in this case if original resistivity is rho? What will be the new resistivity? Yes, if wire is stretched, what will be the new resistivity? Wire is stretched in such a way that its length is doubled. 4 times. Okay. Anyone? Yes, area decrease हो जाएगा. Okay. Online student, कोई तो बता दो भाई. कोई नहीं बता रहा.
Resistance will increase.
I am talking about resistivity.
there is no change in resistivity, I
There
guess.
will be again no change in resistivity
Because it does not depend on the length and direction.
hello.
It depends. Hello, it does not depend on
बढ़िया भाई
all these
बताओ.
factors. Only the nature of
मैं
the.
क्लास में हूँ भाई.
Hello.
हाँ हाँ आता हूँ. ठीक है भाई. ठीक. Yes, resistivity will be
It is
same.
will be is the same because it does not depend on the other factors. It depends only on the nature of the object.
Material, yes, right. So if we double the length of the wire, there will be again no change in resistivity. Third point, if we have a wire with certain length L and with certain area of cross section A, and this time this wire is stretched in such a way that the length of the wire is double and its cross sectional area will be what? If we are stretching the wire, we are not cutting the wire, we are stretching the wire. In that case, if wire is stretched, length will be doubled and area of cross section will be decreased by the same factor, which means this will be A by 2. And why is it so? Why is it so? Why is it happening that on stretching the wire, area will be half? Why is it so? There must be some reason, na? There must be some logic. Why is it happening?
Because
The
it is
reason is
dependent.
because, yes.
It is dependent on area and length of the
No,
material.
my question is why is it so that
Sir,
there, if
area of
we
cross section is inversely proportional
inversely proportional to what?
to resistivity.
Okay.
Resistance.
The logic is we have,
R is
okay,
equal to
if I state it in this way, we have a wire and we stretch it. Will its mass change? Or mass will be same? Mass will be same. So before stretching mass and after stretching mass will be same. Mass is what? Density by volume. So this will be density into volume, before and after. There will be no change in density. Density factor will cancel out. So volume is what? Volume is base area into length. So this will be A1 L1 A2 L2. And now you will get a relation A1 by A2 is equals to L2 by L1, which states that area is related with length inversely, which indicates that if you will increase length by a certain factor, accordingly area of cross section will decrease. That's why it's happening. But this is not the question. Question is, if we have a wire with length L and area of cross section A, and let's say its resistivity is rho, first question is, what will be the resistivity of new wire which have length double of the original wire and area of cross section is half? What will be the resistivity of the wire?
The
Resistivity,
resistivity will be same because it does.
resistivity will be same, but resistance will change. So resistance mu will be n square times resistance old. What is n? What is n here? N is the factor with which length is changed. With which length is changed. So in this case, I have doubled the length. So n factor is 2, and according to the relation, R new will be 2 square times R old. That is, new resistance will be 4 times greater than original resistance of the wire or old resistance of the wire. So resistance of the wire depends on nature of the material of the wire, dimensions of the wire, temperature of the wire. On the other hand, resistivity depends only on the nature of the wire, not dimension. It is independent of dimension. And resistivity is also connected with temperature. Resistivity depends on temperature also. If we will change the temperature, resistivity will change. And if resistivity is changing, accordingly resistance will change of the wire. Understood or any doubt in it? Yes.
Understood, sir. Understood.
Last point. Last point is. Last point is, we have a wire of certain length L, and I will cut this wire into 3 equal pieces of length. This length is L by 3. This length is L by 3. This length is also L by 3. Question is, if original resistance of the wire in its original form is R with resistivity rho, what will be the resistivity for 3 different pieces of the wire? So if we are talking about resistivity, it is independent of the dimension. So this will be rho, rho, and rho. Second point, if I am cutting the wire, will it change its cross-sectional area? I am not stretching the wire, I'm just cutting it. So on cutting a wire, there will be no change in area of cross-section. A will be same for all the 3 pieces of the wire. Now you can look at it in this way. R is equal to rho L by A. And on cutting, rho is not changing, which means rho will be constant value. Area is not changing, A will also be constant value. So we simple have a relation between R and L, which is R directly proportional L, which indicates that whatever change will be in length, the same change will be in R factor. If I am changing length by 1/3 factor, R will also be changed by 1/3 factor, which indicates new resistance of the 3 pieces individual. R new will be 1/3 of R old, which clearly means if I have this wire with, let's say, resistance 10 ohm, and I am cutting it into 3 different pieces, so resistance of individual piece will be how much?
1/3.
R by 3. Are you getting it? If original is R and I am changing length by a factor of 1/3, same change will be in R. So this will be 10 by 3. So R new will be 1/3 of original, that is 10. Understood or any doubts? Yes, understood or any doubt?
Understood, sir.
Okay. Next we have a simple quantity which is known as electrical conductivity. Electrical conductivity. What is electrical conductivity? Electrical conductivity is given by sigma and it is the reciprocal of resistivity. Reciprocal of resistivity is known as electrical conductivity. Now, what is the unit for resistivity? Unit for resistivity is ohm meter. So what will be unit for electrical conductivity? This will be 1 upon ohm meter, which is given as ohm inverse meter inverse, or in some book we write it as ohm inverse meter inverse, or mohometer inverse, or Simon meter inverse. So there are different units for it, or different name of the same unit. Understood? Like electrical conductivity, there is one more quantity which goes like electrical conductance. Electrical conductance. So electrical conductance is given by, let's say, C, or in some book we take it as K. So electrical conductance is defined as the reciprocal of resistance. 1 upon R is electrical conductance. Unit for resistance R is ohm. So unit for conductance will be ohm inverse or mho. Understood? Sometimes ohm inverse is also written as this in books. Means in reverse direction. Understood? Okay. Now let's start chemistry. This chapter is completed. All the core concepts have been covered. In chemistry, what is the topic in chemistry? Yes. In chemistry, I think we have done structure of atom. Yes or no?
Yes, sir.
Okay. Now we can discuss another chapter, which is classification of elements and periodicity in properties. Classification of elements and periodicity in properties. Periodicity in properties. So there are different methods, or there are different attempts to classify the elements. What was the first one? What was the first attempt to classify the elements? Initially, elements were not so large in numbers. So there was the simplest classification, which is done by John Dalton. And it was the classification of element on the basis of their physical properties. On the basis of their physical properties, Dalton classified elements into two broad categories, which are known as metals and non-metals. Metals have different properties, non-metals have different properties. So initially the classification was like metals and non-metals only. But after some time, when further elements were discovered, some of the elements were having intermediate property, which means some elements were found in such a way that their properties were in between metals and non-metals. And now these elements are known as metalloids. So on the discovery of metalloids, the classification of Dalton was discarded. So we need another classification. After John Dalton, we have second classification, which was given by Proust. Proust's hypothesis was that all the elements or all the atoms are made up of hydrogen atoms. So atoms will have atomic mass of integral multiple of atomic mass of hydrogen atom. What is the atomic mass of hydrogen atom? Yes. Atomic mass of hydrogen atom is 1. What is the atomic mass of carbon atom? 12. So we can clearly say that mass of carbon is 12 times mass of hydrogen, which means mass of carbon is integral multiple of mass of hydrogen. So this was the hypothesis proposed by Proust. But again, this is not valid for different elements and atoms, because we have certain atoms which have atomic masses in such a way that they are not integer. For example, copper. Copper has atomic mass what? 63.5, which is not integral multiple. Or chlorine atom, which has 35.5. So this classification is also not valid. Then we have third classification, डोबेलाइनर ट्रायड. ये तो बहुत फेमस है, यहाँ से कहानी स्टार्ट होती है मेन बुक के अंदर, तो मैं यहीं से स्टार्ट कर रहा हूँ. डोबेलाइनर ट्रायड्स क्या कॉन्सेप्ट है ये? Dobeliner triads. This concept states that if we will arrange elements in increasing order of their atomic masses in the group of 3, so let's say we have 3 different elements, element A, element B, element C, and these elements are arranged in increasing order of their atomic mass, then it has been observed that mass of the middle element will be average of mass of remaining 2 elements. That is, mass of B element will be the average of mass of A and C. And we have an example for it. Let's say we have a triad of lithium, sodium, and potassium. If we will look at mass of lithium, this is 7, this is 23, this is 39. You can observe that if you will take the average of mass of lithium and mass of potassium, it will be 7 plus 39 by 2, which will be how much? 39 plus 7 will be how much? I think 46 divided by 2, which is 23, which is same as mass of sodium. So this is the concept given by Dobereiner. He stated it as, if we will arrange elements in increasing order of their atomic masses in the group of 3 elements, then the middle element or middle atom will have atomic mass as average of remaining 2 elements or atoms. But this classification is again not valid for all of the elements. So we have only few triads which will have this condition to be followed. And after that, for other elements, it will not be possible to hold this property. Another triad is Cl, Br, and I. This is first triad. This is second. And there is one more, third, that is calcium, strontium, and barium. But other elements do not form the triad. So again, we need another classification. And after Dobereiner, we have Newland's law of octave or Newland's classification. Newland's law of octave. Again, you all know about it. What is Newland's law of octave? Newland's law of octave states that if we are arranging the elements in increasing order of their atomic masses, then every eighth element will have similar property to the first element, which is same as in music notes. Eighth music note has same, क्या बोलना चाहिए मुझे? Eighth music note has नोट के लिए कुछ स्पेशल वर्ड होगा म्यूजिक में, नहीं पता मुझे. ट्यून बोल लेता हूँ. ट्यून वैसे बेटर वर्ड है नहीं, बट मुझे कुछ नहीं मिल रहा वर्ड. So if we arrange elements in increasing order of their atomic masses, eighth element will have similar behavior or similar property as the first element, and same is true in music notes. Eighth note is similar to the first note. This is the concept of Newland. And again, this classification was not valid for all the elements. It was again valid for only few elements. I think this classification was valid till calcium element. After calcium element, there will be certain irregularities in the pattern in Newland's octave classification. And there will be a question like this: how many elements were known at the time of Newland? Yes. How many elements were known at the time of Newland? 63? 63 is not the correct answer. 63 were the elements known at the time of Mendeleev. Newland's classification came first. So, how many elements were known at that time?
56.
Yes, there were 56 elements known at the time of Newland, and it was valid only till calcium. After that, there will be gadbad, valid till calcium. Understood? ये कहाँ मिलेगा तुम्हें इंफॉर्मेशन? 10th क्लास के एनसीईआरटी में मिलेगा. उसमें बहुत अच्छा लिखा हुआ है क्लासिफिकेशन. वहां से पढ़ोगे तो सब समझ में आ जाएगा. बहुत आसान लिखा हुआ है. Next point is, what are the limitations for Newland's law of octave? First limitation is that it is not valid for all the elements. And second limitation is that there were no discovery of noble gases at that time, and there were no group or no arrangement for noble gases in this classification. Then after Newland, we have another classification which is Lothar-Mayer's atomic volume curve. Atomic volume curve, or you can also call it as Lothar-Mayer's classification. This was the most precise classification till Mendeleev. In fact, Mendeleev concluded its periodic table from Lothar-Mayer's curve. And the curve is like this. We have two axes, x-axis and y-axis. And we will take some property of the element on y-axis and atomic mass on the z-axis. So atomic mass on the z-axis and property on the atomic axis, y-axis, and this property is atomic volume. In some book, it is taken as density of the element. And then there will be a curve plotted which goes like this. Like this. And this curve has certain elements nearby each other, which indicates that these elements have similar properties. This was the classification of Lothar-Meyer. After Lothar Meyer, we have most famous classification, that is Mendeleev's classification. Mendeleev's periodic table. So what are the key points in Mendeleev's periodic table? First point, this periodic table is based on Mendeleev's periodic law. Mendeleev's periodic law. What is Mendeleev's periodic law? It states that if you will arrange the elements in increasing order of their atomic masses, there will be repetition in the properties of the elements after a regular interval. Second important point in Mendeleev's periodic table is that this periodic table is based on atomic mass, and along with atomic mass, this periodic table also take into account chemical properties of the element. Chemical properties of the element, like during the formation of periodic table by Mendeleev, he also take care of chemical formula of oxides and chlorides. Oxides of elements and chlorides of elements, hydrides of elements. And the reasoning was like this: if certain elements have same type of chemical formula of oxide, they will have similar chemical behavior. Let me give an example for this. Let's say we have lithium, sodium, potassium, rubidium, and cesium, and all of these are treated with oxygen. They react with oxygen. So you will notice that lithium will form lithium oxide, sodium will give sodium oxide, Li2O, Na2O, K2O, and Rb2O and CS2O. The interesting point is, in oxides of all these elements, chemical arrangement is same, which is given by M2O form. So all these elements have similar chemical behavior or similar chemical properties, which can be investigated by valency and oxidation number. If we will look at the valency of these all elements, they all have same valency, that is 1. They all have same oxidation number, that is +1. They all are metals. They all form same type of chlorides and hydrides, which clearly indicates that they have similar chemical features. And this was the most important property in the formation of Mendeleev's periodic table, which makes it a successful periodic table for a certain time period until we have or modern periodic table. Until that time, Mendeleev's periodic table is successful. And there were other reasons also for the success of Mendeleev's periodic table, that is, it helps us to discover new elements. It helps us to discover new elements. And how it happens? During the formation of Mendeleev's periodic table, Mendeleev left some gap in the periodic table. And he concluded that the element which will come at that particular position will have the following properties. On the basis of those properties, elements were discovered, and it is far more easier to discover someone with properties other than the element about which we know nothing. So that's why Mendeleev's periodic table was a success, because it helps us to discover new elements, and the properties which was predicted by Mendeleev was almost similar to the properties of the elements which was discovered. Are you getting it? Are you getting it? Yes or no?
Yes, sir.
Okay. Next important point in Mendeleev's periodic table is it classifies the elements of similar chemical properties in a single group to very precise. And for this, if he has to break the order of atomic number, he will break it. In Mendeleev's periodic table, it is observed that there are certain elements which have greater atomic mass but are plotted or are placed before the elements with lesser atomic mass. One of the example is between cobalt and nickel. Right? In cobalt and nickel has greater mass, so it has to be come after cobalt. But in Mendeleev's periodic table, nickel is placed first, and after nickel we will have cobalt. And the reason for this is that if to make a group of elements with similar chemical property, we have to change the order of atomic mass, we will change it. Understood or any doubt? In this concept, there can also be a question about a statement of Mendeleev's periodic law. So Mendeleev's periodic law is given in the form as the physical and chemical properties of the elements are periodic function of their atomic masses. Chemical and physical properties of elements are periodic function of their atomic masses, which implies that if you will arrange the elements in increasing order of atomic masses, there will be repetition in the properties at regular interval. Another point about Mendeleev's periodic table is that there were total 63 elements known at that time. In Mendeleev's periodic table, we have 7 periods that are horizontal rows. They are 7, and vertical groups or vertical rows, which are known as groups, they are 8. There were no different place for noble gases in Mendeleev's periodic table. After the discovery of noble gases, he added another group to his periodic table, and that group is known as zero group. So in periodic table, we have one extra group, which is known as what? Zero group. And in this zero group, we have only noble gases. Understood? So originally, there were only 8 groups. After the discovery of noble gases, there will be 8 groups already present, and one group is added extra, that is zero group. Zero group was added for what? Noble gases. Understood? Next question may be like this. This is very basic information. Like the elements which was not discovered and Mendeleev told about the properties of these elements, he named them. For example, he named an element as Ica aluminium. Now the question will be, which element is Ica aluminium? So Ica aluminium is gallium. Which element is Ica silicon? Yes, Ica silicon is germanium. Understood? Understood? एक और होता है इसमें, इक्का एल्यूमिनियम, इक्का सिलिकॉन, और कौन सा था? जर्मेनियम हो गया, गैलियम हो गया, एक और था, 10 होते हैं ना। इक्का बोरॉन क्या, कौन सा एलिमेंट होता है वो? एल्यूमिनियम तो नहीं है। इक्का बोरॉन कौन था वो? यस एनिमल, इक्का बोरॉन कौन है? इक्का बोरॉन, विच एलिमेंट इज इक्का बोरॉन? स्कैंडियम, स्कैंडियम, ओके। Defects in Mendeleev's periodic table. The first and most important defect is position of hydrogen. Mendeleev could not decide the position of hydrogen, where hydrogen has to be placed. And this is the problem till now also. In modern periodic table, again, hydrogen has no fixed position. Second important point or limitation of the Mendeleev periodic table is position of isotopes. What are isotopes? Isotopes are the elements with same atomic number but different atomic masses. Since Mendeleev's periodic table is based on atomic weight, so isotopes has different atomic masses, which means all the isotopes must have different place in periodic table of Mendeleev. But this is not the case. He put all the isotopes of an element into the same slot. Right? So this is again another limitation or defect in Mendeleev's periodic table. And another one problem was about the atomic mass. I already told you that in Mendeleev's periodic table, some of the elements with greater atomic mass was placed before the elements with lesser atomic mass. So this is another problem in it. Now finally we have, which is known as modern periodic table. Yes, modern periodic table. What are the main points about modern periodic table? First point is modern periodic table is based on MPL. MPL stands for modern periodic law, which states that if we arrange elements in increasing order of their atomic number, there will be repetition in properties at regular interval of the elements. And in other words, it is also given as the physical and chemical properties of the elements are periodic function of their atomic number, not atomic mass. Before modern periodic table, it was Mendeleev's periodic law, which is the physical and chemical properties of elements are periodic function of their atomic masses. But in modern periodic table, we have a change in law, that is modern periodic law, and it states that the physical and chemical properties of the elements are periodic function of their atomic number, not their atomic mass. Question is, who told it or who discovered this fact that the properties of elements are periodic function of their atomic number, not atomic mass? What is the name of scientist who discovered it? Yes. Who discovered the fact that the physical and chemical properties of elements are periodic function of their atomic number, not atomic mass? Who discovered it? Henry Moseley. Henry Moseley discovered it. Henry Moseley. Understood? कुछ तो क्या मेंडलीव का एटॉमिक मास है, हाँ, इसके पास एटॉमिक नंबर. So this was discovered by Henry Moseley. What is the main points about modern periodic table or long form modern periodic table? Let's discuss about the periods. How many periods are there in modern periodic table? 7. Yes. And what is the information about these 7 periods? First period contains 2 elements, hydrogen, helium. Second period contains 8 elements, lithium to neon. And third period contains again 8 elements, 11 to 18, that is sodium to argon. Second and third period are known as short period. Period number 1 is known as very short period. Then we have fourth period, which contains 18 elements, and fifth period, which also contains 18 elements. Fourth period starts from potassium and goes to kryptonium. Fifth period starts from rubidium Rb and it goes to xenon Xe. All these period means fourth and fifth has 18 elements each. These periods are known as long periods. Then finally we have sixth and seventh, which are the longest one, and they have 32 elements and 19 elements. This is important point. Sixth period has 32 elements. and seventh period has 19 elements, while seventh period can accommodate more elements. So if we discover further elements, it will go in seventh period. Are you getting it? Sixth and seventh period are known as long period or longest period. Then we have groups. How many groups are there? 18 groups are there. Group number 1 is known as alkali metals. Group number 2 is known as alkaline earth metals. Group number 16. Group number 16 is what? Oxygen family, right? Yes, oxygen family is known as chalcogens. Group number 17, halogens. And group number 18, noble gases. रिमेनिंग की नेमिंग तो नॉर्मली करते हैं, बोरॉन फैमिली, कार्बन फैमिली. आर यू गेटिंग इट?
Yes, sir.
ओके. कुछ बच्चे बात कर रहे हैं, बात मत करें, पढ़ाई करें. Third point about modern periodic table is that this periodic table is divided into blocks. Yes, how many blocks are there? 4 blocks. S block, P block, D block, and F block. Understood? Let me give some rough idea about it. Okay, this is a rough sketch for periodic table, long form of periodic table. Here we have group number 1, group number 2. Here we have group number 3 to group number 12. Then we have group number 13 to group number 15. This complete is S block. This complete is P block. And this one is known as D block. And then finally we have last two series at the bottom of the long form periodic table. This is known as F block. Some important points about S block, P block, D block, and F block. In S block, we have all elements as metals. In S block, we have all elements as metals except hydrogen. In D block, all elements are also metals. In F block, all elements are also metals. Interesting point is about P block. P block is the only block which have all type of elements. At the zigzag line, it has metalloids. On the right hand side of zigzag, it has non-metals. And on the left hand side, it has metals. This is rough idea about the modern periodic table. Are you getting it? Now, there will be question like, what is the general electronic configuration of for S block elements, P block elements, D block elements, and finally F block elements. So for S block elements, we have NS1 to 2. For P block, we have NS2, NP1 to 6. For D block, we have what? We have NS2, N minus 1D, 1 to 10. For F block, we have NS2, N minus 2F, 1 to 14, N minus 1D, 0 to 1, and NS2. This is the general electronic configuration for S block, P block, and D and F block. Understood? In S block, we have only two groups, group 1, group 2. For group 1, this will be NS1, and for group 2, this will be NS2. Then in P block, we have group number 13 to group number 18. For group 13, we will have NS2 and P1. For group number 14, we will have NS2 and P2 and so on. Are you getting it? Yes. Any doubt in it? Any doubt? No doubt. Okay. Now next point will be about how to find out the position of an element in periodic table. So this is about position of an element in modern periodic table. To know the position of an element, you have to find out two information about this element. First information, what is its period number? And second information, what is its group number? If we have period number and we have group number, then at the intersection of period number and group number, there will be a slot, and this slot will be the position of the given element, whatever may be the element in periodic table. Now the question is how to find out period number and how to find out group number. It is very easy to find out period number. If you want to know the period number of any element, check whether the principal quantum number in its electronic configuration or the last cell. So period number will be n. Period number will be given by n, that is principal quantum number. Principal quantum number. This will be for valence shell. If you are looking for group number, then there are different way or different method for different block for the group. So group number for S block, group number will be number of electron in its outermost cell, that is number of ns electrons or number of valence electron simply. Group number for P block will be number of ns and np electrons with 10 plus. So 10 plus ns electron and np electron. Again, ns and np is regarding valence cell. Then for D block, group number will be number of ns electrons plus n minus 1 d electrons. And about F block is very easy to find its group number. Its group number is fixed. Complete F block is in group number third. Complete F block is in group number third. This is period number 6. This is period number 7. So 6 will go here, 7 will go here. This is lanthanoid, this is actinoid series. So in F block it is very easy. In F block we have two series, that is lanthanoid and actinoid. For lanthanoid, period number is 6 and group number is 3. For actinoid, period number will be 7, but group number will be same as in case of lanthanoid, that is third group. Are you getting it or any doubt?
No doubt, sir.
चलिए फिर ये कंप्लीट हो गया. अब आपका बचता है ट्रेंड्स इन पीरियोडिक टेबल. ये अगले लेक्चर में करेंगे हम. अभी के लिए आप निकाल लेंगे मैथ्स. व्हाट वाज द लास्ट टॉपिक इन मैथ्स? नीट जेई वाले बच्चे जो बायोलॉजी वाले हैं वो जा सकते हैं. ऐसे तो सब लोग भी जा सकते हैं क्योंकि तुम लोग ध्यान से देते नहीं हो. फिर भी मेरी ड्यूटी बनती है बार बार बोलना, तुम पढ़ लो. मैं अपने काम को लेकर बहुत ईमानदार इंसान हूँ, तुम लोग बिल्कुल नहीं हो. Okay, what is the topic in mathematics?
सर रिलेशन स्टार्ट किए थे.
रिलेशन स्टार्ट किया था. ओके, सो रिलेशन में कुछ बताया रिलेशन में या जस्ट स्टार्ट हुआ था?
We were done with Cartesian product and domain codomain range.
Okay, got it. So relation, let's take a quick recap, then we will move to the function. Uh, uh, let's say we have a relation R which is defined from set A to set B. So according to the definition of relation, relation R will be a subset of Cartesian product A cross B. And according to this definition, if you want to have total number of relations, these relations will be equals to number of subsets of Cartesian product A cross B will be equals to 2 raised to power cardinal number of A cross B. So this will be the total number of relation. If we define a relation R in set builder form, we will write it as x comma y such that x is from set A and y is from set B. Apart from this information that x is from set A and y is from set B, we have another information which is far more important in case of relation, and that information is how x is related with y. What is the relation between x and y element, or what is the connection between x and y? So there will be certain specific relation or connection between x and y which will be given into the question. About x comma y, this is known as ordered pair. This is known as what? Ordered pair. Now if element x is related to element y, in mathematics we will write it as x is related to y, and if x is not related to y, we will write it as x is not related to y, means we will cut r, right? So x is not related to y. Next point is, what is the domain of relation R? Domain of relation R will be the set of values of x such that x comma y must belong to the relation R and x has to be from set A. This is domain of relation R. What is the range of relation R? Range of relation R is the set of all elements y such that x comma y must belong to the relation R and y has to be from set B, right? And if you want to know codomain of relation R, codomain of relation R will be complete set B. If we are having relation from set A to set B, then complete set B will be what? Codomain. Complete set B will be what? Codomain. It is possible that complete set A will be domain. Yes, ऐसा लगता है, but ऐसा है नहीं. In case of relation, it is possible that certain element of set A are not related with any other element of set B, which means complete set A may or may not be the domain of relation. But if it is the case of function, then set A has to be domain of function. और ये कहते हैं रिलेशन में कंप्लीट सेट डोमेन बनेगा ऐसा जरूरी है नहीं. इट इज नॉट द नेसेसरी कंडीशन, बट इन केस ऑफ फंक्शन it is necessary condition that set A has to be domain of the function. तो आपने ध्यान रखना है, if it is relation, you have to check whether all the elements of set A are related or not. If there are few elements which are not related, we cannot take take that element into the domain. For example, let's say I have a relation represented in arrow diagram. This is arrow diagram, and here we have A, B, C, and D, and here we have 1, 2, 3, 4, 5, and so on. And let's say I connect A to 1, B to 2, and C to 3, and I left D without any relation. So this is a relation which is defined from set A to set B. Let's say this is set A and this is set B. I will write it as relation R defined from set A to set B. If I will write relation R in roster form, so this will be like this. First element will come from set A and second element will come from set B. So we will write relation R in roster form as follows. This will be A comma 1, B comma 2 and C comma 3. Since there is no connection of element D, so we cannot take D into the relation R, right? And in this case, if I ask you about what is the domain of relation R, so domain of relation R will be first element of ordered pair according to this definition. X comma y, X we will take as domain. So domain will be what? A comma B comma C, and you can clearly say that domain of relation R in this particular case is not the set A. So it may be or may not. You have to check whether all the elements are connected or not. What will be the range of relation R in this case? Yes, relation R will have range as 1, 2, 3. And what is the codomain? There is no doubt about codomain. It will be complete set B, which is 1, 2, 3, 4, 5. Understood or any doubt? Yes. Okay. Next point about relation is that since relation R is a type of set, so there are different ways to represent a relation. First point is because relation is a set, it can be represented in the form as we represented set. A set can be represented in two forms, roster form or set builder form. So relation also can be given in roster form or set builder form, which is also known as property form or so this one is roster form, this one is roster form, and this one is set builder form, and this one is arrow diagram. So third way to represent a relation may be arrow diagram also. Arrow diagram also is a valid way to represent. Sometimes relations are also represented on Cartesian plane. So Cartesian plane can also be used to represent a relation. It will all depend on the situation and the question how we are representing a relation. Any doubt in it? Next point is types of relation, which is a very important concept. Types of relation. First will be the smallest relation. First one will be the smallest relation, simplest relation, which is known as empty relation. Because relation is a set. So it may be empty set, na? Empty relation or void relation. What will be this type of relation? This relation will be given by phi, and you can state that empty set is a subset of every set, right? So if we have, let me write it as, if we have a relation R defined from set A to set A, we write it as relation R is defined on set A. This is also known as binary relation. If set is working for both domain as well as codomain. In this case, we have first one empty relation or void relation, which is given by phi. Because phi will be a subset of every set. So phi is also a subset of A cross A, and hence phi is known as empty relation. For example, let me define a relation R1, which is x comma y, such that x is wife of y. And if I write it as Katrina comma Sumit, what do you think? नहीं है? Yes or no? भाई किसी और की है वो? अरे हाँ या ना जालिमो? So we can clearly say that there will be no element in relation R1. Yes or no? Why is it so? Because there is no relation between this prani and this prani. Yes or no? Is not related with this person. Understood? So this is the smallest possible relation. Let's say we have largest possible relation. Could you guess which will be the largest one? If empty is the smallest, which will be the largest relation? Universal or set by itself, because every set is a subset of itself and relation is a subset. So we can define another relation which is largest possible, and this is known as universal relation. Universal relation, right? Universal relation will be given by U. You can also say that A cross A is a subset of A cross A. So if you will take A cross A complete as a relation, this relation will be known as universal relation. For example, if I have element A as 1, 2, and I define A, which will be 1, 1, 1, 2, 2, 1, 2, 2, and I name a relation R1, let's say, and R1 is defined by 1, 1, 1, 2, 2, 1, 2, 2. So you can clearly say that R1 relation is nothing but A cross A, and A cross A is a subset of A cross A, which means R1 is a universal relation. Basically, universal relation is a relation in which all possible connections will be included in the set. For example, Let's say we have a relation R which is defined on set A. Set A is the set of students of ADCI, and the relation goes like this: x comma y such that difference between the height of x and y is less than 10 meter. Are you getting it? So if you will select any two element from the set A, which means if you will select any two students from ADCI, no matter which two student you are selecting, any two student, and you take the difference of height, it will always 10 meter. Yes or no? Is it possible? Is it possible to select any two student such that the difference of height will be greater than 10 meter? हो ही नहीं सकता है। आज की डेट में तो एटलीस्ट पॉसिबल है नहीं। अगर हम डायनासोर वाली डेट में चले जाए तो पता नहीं हाइट का क्या रेंज रहा होगा, बट आज की जो हाइट है ह्यूमन बीइंग की, उसके हिसाब से तो कभी भी गड़बड़ नहीं करेगा, राइट? कोई भी दो स्टूडेंट अगर मैं सिलेक्ट करता हूं तो हाइट का डिफरेंस विल ऑलवेज बी लेस देन 10, विच मींस हर एक स्टूडेंट का पेयर इंक्लूड हो जाएगा, और इसीलिए हम इसे क्या बोल रहे हैं? दिस विल बी अ यूनिवर्सल रिलेशन। अंडरस्टूड और एनी डाउट? यस,
No doubt,
okay.
sir.
Next relation is which is known as identity relation. Identity relation. Identity relation is a relation which is given by I on set A, which will be equals to A comma A, such that A belongs to set A. And in the form of words, we state it as a relation will be an identity relation if each element of set A is related to itself only. So the condition is each element of set A is related to itself only. Is related to itself only. Yes or no? For example, we have set A which is 1 comma 2 comma 3, and a relation R1 is defined on it 1 comma 1 2 comma 2. Another relation R2 is defined 1 comma 1 2 comma 2 3 comma 3, and another relation R3 is defined 1 comma 1 2 comma 2 3 comma 3 and 1 comma 2. Which one will be identity and which is not identity? So the condition for identity relation is if you are having a relation on set A, each element of set A has to be related by itself. So if you will look at R1, 1 is related with itself, 2 is related with itself. But there is one more element in set A, that is 3. And there is no relation of element 3 in relation R1. So relation R1 is not identity relation. For identity relation, each element must relate to itself only. Second R2, we have three elements in set A, and all the three elements are related with itself. One is related with one, two with two, and three with three. No elements in set A is left. So this will be the example for identity relation. Next R3. In R3, one is related with one, two is related with two, three is related with three. There is no problem till here. But one extra element is there, 1 comma 2. So one is related with itself and one is also related with 2. And the definition is one has to be related itself only, which again implies that this relation is not identity. Understood? Next relation which we are going to define is reflexive. Reflexive relation. What is the condition for reflexive relation? If we have a relation R defined from set A to set A, then relation R will be reflexive if let me write it as relation R is reflexive if and only if A comma A belongs to relation R for all elements of set A. If I will convert it into words, it will be like this. A relation R will be a reflexive relation if all the elements of set A are related with itself. All the elements of set A must relate with itself. Right? Listen carefully to the statement. In case of identity, I have stated it as a relation will be identity relation if each element of set is related to itself only. And in case of reflexive, we are saying that a relation R will be a reflexive relation if each element of set is related to itself. We are not using the word only. So in case of reflexive, necessary condition is each element of set A has to be related with itself. Apart from this, element of set A can also have relation with another element also. For example, we have set A as 1, 2, 3, and we are having some relation R1, 1, 1, R2, 1, 1, 2, 2, R3, 1, 1, 2, 2, 3, 3, R4, 1, 1, 2, 2, 3, 3, 1, 2. This is R4. So what do you think about R1? Is it identity relation? No. R1 is not identity relation because there are two elements in set A, 2 and 3 which are not in relation with itself. Is it reflexive? For reflexive, all elements, look at this. For reflexive, all elements must be related with itself. So there is only one element which is related with itself. Two elements are left, 2 and 3. So this is not reflexive. Right? R1 is not reflexive on set A, but R1 is reflexive for element 1. Question will be in two different formats. One format is about individual element, and one format will be about overall relation. So overall relation R1 is not reflexive, but R1 is reflexive for element 1. Now look at relation R2. We have 1, 1, 2, 2, but there is no element like 3, 3. So is it identity relation? No. Is it reflexive? Again, no, it is not reflexive because element 3 is not related with itself. But we can state that relation R2 is reflexive for element 1 and it is also reflexive for element 2. In other sense, it is also stated as 1 has reflexivity. Element 2 has reflexivity. Element 2 has reflexivity means 2, 2 is in relation. 3 has no reflexivity, which means 3, 3 is not in relation. अभी देखते हैं R3. What about R3? Is it identity? Yes. Is it reflexive? Yes. So we can say that identity relation is always reflexive. Identity relation is always reflexive. Every identity relation is reflexive. But is it true for converse? Let's look at R4. R4 is not identity, but it is reflexive. So every identity relation is reflexive, but converse is not true. A reflexive relation may or may not be identity, but a identity relation guaranteed will be reflexive. Are you getting it? Understood or any doubt?
Understood, sir.
Okay, after reflexive we have symmetric relation. How to check whether a given relation is symmetric or not? So if we have a relation R which is defined set A to set A, and in this relation if A comma B belongs to R, and we will check for B comma A. If A comma B belongs to R, then if A comma B belongs to R, this implies B comma A must be in relation, which means a relation will be identity relation if for all ordered pairs there is a symmetric ordered pair. In simple words, it means if A comma B belongs to R and B comma A also belongs to R, and this is true for all the pairs. This is true for all the elements of set A. Then we will say that relation R is a reflexive relation. Again, the question may be about an individual element, or the question may be about overall relation. If it is it about overall relation, you have to check for all the elements. If there is at least one element for which symmetry is not hold, the relation will not be symmetric. It may be symmetric about individual elements, but overall relation will not be a symmetric relation. Let's take an example. A is 1, 2, 3, and let me have relation R1, 1, 1, relation R2, 1, 1, 2, 2, 3, 3, R3 is 1, 1, 1, 2, 2, 1, and R4 is 1, 2. Okay, what about relation R1? Is it identity? R1 is not identity. Is it reflexive? R1 is not reflexive. Is it symmetric? Is it symmetric? Relation R1? In relation R1, we have element 1, 1. So A is 1, B is also 1. Right? If A comma B is there, B comma A must be there. A comma B is 1, 1. B comma A is also 1, 1. So 1, 1 has symmetry about itself. So this will be a symmetric relation. Are you getting it? Are you getting it? 1, 1 has symmetry about itself. Because value of A is 1, value of B is also 1, A comma B is 1, 1, B comma A will also be 1, 1. So this is a symmetric relation. What about R2? Is it identity? Yes. Is it reflexive? Yes. Is it symmetric? Yes. Each element is symmetric about itself. 1, 1 has symmetry element 1, 1, which is it itself. 2, 2 has symmetry element 2, 2. 3, 3 has 3, 3. So identity, reflexive, and symmetric. So could we say that every identity relation? Yes. Any identity relation will always be reflexive, will always be symmetric. But converse is not true. May or may not be. For example, R3. R3 is not identity. R3 is not reflexive, but R3 is symmetric. Yes? What about R4? Is it identity? No. Is it reflexive? No. Is it symmetric? Understood. Next we have transitive relation. What is the condition for transitive relation? If we have a relation R which is defined from set A to A, and A comma B belongs to R, B comma C belongs to R, then A comma C must be in relation R. For all A comma B comma C belongs to set A. Interesting point is, if this condition holds, then we will look for this condition. Are you getting it? If this condition is in relation, then for the transitivity, we will look for this condition. And if this condition is not valid, then we will say the relation is not transitive. Again, for the transitivity of overall relation, you have to check for all possible combinations. You have to check for all the elements, right? A relation may have transitivity about certain elements, but the same relation may have certain elements which has no transitivity. So in that case, if I have at least one element for which transitivity is not hold, I will state that the given relation is not transitive. So for a relation to be transitive, it has to be transitive for all the elements. Understood? Let's say again we have same set A, 1, 2, 3, and I have a relation R1 which is 1, 1. I have a relation R2 which is 1, 1 and 1, 2, 2, 1 and that's it. Or let me write one more element, 2, 2. Another relation R3 is 1, 1, 2, 2, 3, 3. Another relation R4 is 1, 2. Now you have to check first relation. Is it identity? Yes or no? R1 is identity, yes or no?
Yes, sir.
R1 relation is identity or not? No,
No, sir.
because two elements are not related by the definition. Is it reflexive? No. It is reflexive for element 1, but it is not overall reflexive. Is it symmetric? Is it symmetric? 1, 1, 1, 1 is there. Element has symmetry by itself. This is symmetry. Is it transitive? This is very important now. If we have A, B and B, C, then we will look for A, C. But if there is only one element, one and only one ordered pair, then it will be guaranteed transitive. So you have to remember this point. If in relation there is only one ordered pair, it will be transitive. So the given relation is transitive. Condition नहीं बनेगा इसमें, because condition is if A, B and B, C, then we will look for A, C. But if there is only one element, तो ये condition बना ही नहीं इसमें. तो एक एलिमेंट को ट्रांजिटिव बोला जाता अकेला अगर. What about second? Is it identity? R2 is identity, yes or no? R2 is identity, yes or no?
No, sir.
No. Is it
No, sir.
reflexive? Is it reflexive? No. Is it symmetric? Check the symmetry.
Yes,
1,
sir.
1 is there. 1, 1. 1, 2, 2, 1 is there. For 2, 1, 2 is there. For 2, 2, 2, 2. Symmetric. Is it transitive? Now we will look transitivity for all the elements. For example, first element is 1, 1. Regarding element 1, 1, I have 1, 2. So this is A, B and B, C. Then we must have A, C. What will be A, C in this case? 1, 2. Yes or no? Yes or no? If this is A, this is B, this is B, this is C, then this will be A, this will be C. So 1, 1 belongs to R. 1, 2 belongs to R. So 1, 2 must belongs to R. And this is true. So transitivity of element 1, is valid. Yes or no? Next element we have 1, 2. And then we have 2, 1. So it must have 1, 1. And this is the element 1, 1. So transitivity for element 1, 2 is also valid. Now we will look for the third element. 2, 1 is there. 1, 1 is there. So 2, 1 must be there, which is the element by itself. 2 comma 1 is there, 1 comma 2 is there. So 2 comma 2 must also be there, which is again given in the relation 2 comma 2. So 2 comma 1 has transitivity. An interesting point is 2 comma 1 has transitivity about two elements. 2 comma 1 has transitivity regarding 1 comma 2 and 2 comma 1 has transitivity regarding 2 comma 2 also, right? So you have to check all the possible combinations. Next element is 2 comma 2. If we have here 2 comma 2 and 2 comma 1, 2 comma 2 and 2 comma 1, then we must have 2 comma 1, that is this element by itself. So we can clearly say that relation R2 is transitive. Yes, because transitivity for all the elements are satisfied. हमने एक एक एलिमेंट को चेक किया. What about R3? Is it identity? Yes. Reflexive? Yes. Symmetry? Yes. Transitive? Yes. Which means every identity relation is reflexive, is symmetric, and transitive. But converse is not true. What about the R4? So
Sir,
in
I have doubt.
R4 we have 1 minute. In R4 we have only one ordered. I already told you if there is only one ordered pair, a single ordered pair, you have to check nothing. It will be guaranteed. Is it reflexive? No. Is it identity? No. Is it symmetric? No. But it is. Yes. What is the doubt?
सर R3 सिमेट्रिक कैसे हुआ और ट्रांजिटिव कैसे?
2,2. किस रिलेशन के बारे में बोल रहे हैं R2, R3 और R4?
R3
R3 में आइडेंटिटी तो है ही है. Yes or
yes sir,
no?
identity and reflexive I know, but I have doubt in symmetric and transitive.
Symmetric. Okay. Let's look it in this way. We have element 1 comma 1. This is A, this is B. So for symmetry we must have B comma A. If I will put the value of B comma A, this will be again what? 1 comma 1. So 1 comma 1 is the element which is symmetric about itself. Symmetry element of 1 comma 1 is 1 comma 1 itself. That's why we are saying that 1 comma 1 has symmetry about itself. So this will be symmetric. And this is true for 2 comma 2 and 3 comma 3. Understood or any doubt?
Yes sir, and what about transitive?
Transitive, it will be transitive because there are only individual ordered pairs, single ordered pairs. If there are only single ordered pairs, it will be transitive because the condition of transitivity will be checked if and only if we have A comma B belongs to R and B comma C belongs to R. Only then we will check for A comma C. But in this case, we have only A comma B and there is nothing like B comma C. So this will be transitive. This will also be transitive because there is only one single ordered pair separately.
Okay.
So if we have
Okay, sir.
individual ordered pairs which are not related with itself, which are not related to other ordered pairs, then the relation will be transitive. You have to remember this point actually. It is very confusing. तो ये आपने ध्यान रखना है. अगर एक अकेला ordered pair है तो guaranteed क्या होता है? Transitive. गड़बड़ कब होगी? जब वो एलिमेंट के साथ दूसरा एलिमेंट भी आ जाए तो फिर मुझे चेक करना पड़ता है थर्ड एलिमेंट के लिए कि वो है कि नहीं. अगर एक अकेला है तो ट्रांजिटिव होगा. अंडरस्टूड और एनी डाउट?
Understood sir.
Okay. Now the last point we are left with equivalence relation. What is the equivalence relation? Equivalence relation is a relation which is which is reflexive, which is symmetric, and which is transitive also. So if I have a relation which is reflexive, symmetric, and transitive, then this relation is said to be equivalent relation or equivalence relation. For example, we have identity relation, and I already explained to you identity relation is reflexive, identity relation is also symmetric, identity relation is also transitive, which means identity relation is an example of equivalence relation. Identity relation is an example of equivalence relation. Understood?
Yes, sir.
Okay.
Yes, sir.
Relation is completed. Relation is completed from 11th and 12th. नेक्स्ट लेक्चर में क्वेश्चंस करेंगे इसके. Now we have general aptitude. लास्ट टॉपिक हमने क्या किया था जनरल एप्टीट्यूड में? ट्रेन. हाउ मच टाइम डज a train take to cross a pole, a signal post, or a man standing at the platform? And another case was how much time it will take to cross another train, whether the trains are moving into the same direction or they are moving in opposite direction. Understood? Or any doubt? Now we will have another topic. अब कौन सा टॉपिक कराऊं भाई? इंपॉर्टेंट सब कराऊं. One minute, let me check the syllabus. In general aptitude, we have simplification of numbers, fraction, HCF, LCM, average, ratio and proportion completed, percentage completed, simple and compound interest, profit loss, work and time completed, time distance completed, boat string completed. Okay, so we can complete simple interest and compound interest. Yes, there is only one formula in this topic. Simple interest. First point is principal amount. Principal amount is the amount which is taken or given initially. It is given by P. Second is interest. Interest amount is the extra amount which are giving or taking on the given amount or taken amount, that is principal amount. That is known as interest. It is given by R percent, per annum or monthly. How is it? Then we have simple interest. simple interest. Simple interest is given by SI. So there's the formula for simple interest. SI is equals to P into R into T divided by 100. General means general concepts which are used in daily life. Simple से point. Basic mathematics और foundation mathematics. 6th 7th 8th में जो सिखाया जाता है. लेकिन बच्चे बहुत मेहनती हैं, भूल जाते हैं चीजों को, बार बार सिखाना पड़ता है. Okay. This single formula can be arranged in different format. Like if you want to have principal amount P, you can write it as simple interest into 100 divided by R into T. Similarly, R can be given by simple interest into 100 divided by P into T. And if you are interested in time period, this will be simple interest into 100 divided by P into R. Understood? So this is the concept for simple interest. Question will be straightforward, information will be given, you just have to apply the formula. And along with simple interest, let's say we have compound interest, right? So second part of this topic will be compound interest. What is compound interest? Compound interest is the interest which is calculated on the interest. सन्नी देओल बनने की जरूरत नहीं है. Compound interest is the interest which is calculated on interest on a given amount. So in this case, let's say we have principal amount as P, principal amount as P, rate R% per annum, or it may be in different format, and let's say time taken is n years. So we will calculate the interest first part. When interest is compounded annually, in that case the amount A will be P in bracket 1 plus R by 100 raised to power n. Second is when interest is compounded half yearly. In that case, amount will be P into 1 plus. In case of half yearly, rate will be R by 2 divided by 100, and time period will be converted into 2n. Because if we are taking n years, in terms of half year, it will be 2n. Because 1 year will be divided into 2 parts, monthly, 6 months and 6 months. Third one is when the interest is compounded quarterly. पेपर है ना ऊपर 10-20 को ना हाँ आता ना मैं हाँ हाँ आता ना आता 10 हाँ ज्वाइन करो हाँ हाँ आता ना when interest is compounded quarterly, so in that case rate will be, listen, for the annually we have R, right? For the annually we have R. Half yearly means we are converting the time period into two half parts. So interest will be RY. Quarterly means 4 equal parts. Interest will be RY. Remaining arrangement will be same. So this will be A is equals to P times 1 plus R by 4 divided by 100, and it will be raised to power 4. Yes? Yes or any doubt? Okay. After third, we have fourth point, which is when interest is compounded annually, but time is in fraction, say 3 and 2 by 5 years. Okay. So the case is like when interest is compounded annually, but time period is not complete number. Time is in fraction. Or let me write the fraction as n and p by q. Like we have 3 and 2 by 5. Right? So in that case, we will have the value for A, P into 1 plus R by 100 raised to power n multiplied with 1 plus P by Q times R divided by 100. In case of 3 and 2 by 5, we can write it as P into 1 plus R by 100 raised to power 3 multiplied with 1 plus 2 by 5 R by 100. Are you getting it? Are you getting it? How to deal with fractional time period? Okay. Next point we have fifth, which is if rates are different for different years. When rates are different for different years. And for first year it is R1%, for second year it is R2%, for third year it is R3%, and so on. This is for first year, this is for second year, this is for third year. Yes. So total amount A will be P times 1 plus R1 by 100, 1 plus R2 by 100 for second year, and 1 plus R3 by 100 for third year. And if we are given more information about fourth and fifth year, we will include the same. We will include it in the same way. Understood? Sixth point is last. This is already has been discussed. This is the concept about present value of a material which has been bought in rupees X before certain years. So present worth is given by over original cost of the material divided by 1 plus R by 100 raised to power n. This is the same case as we have discussed in a depreciation concept. How the value of a building depreciates or of a material depreciates. Understood or any doubt? Yes. Now we can solve some simple questions based on the given topic. Find the simple interest on principal amount is given to us rupees 68,000. Interest rate R is 16 and 2 by 3% per annum. This will be how much? 16 into 3, that is 48 to 50 by 3% per annum, I think will be. And time period is given to us 9 months. But the interest rate is in per annum. Means rate is calculated yearly. So we have to convert months into year. So how many years will be there in 9 months? So
3
total
by
months we
4.
have 9 and this will be 12. This will be 3 by 4 years. Now you can directly apply the formula. Simple interest is given by P into R into T divided by 100. So this will be value of P is 68,000. R is 50 by 3. T is 3 by 4 and divided by 100. So let's say divided by 100. So this will cancel out. 3 will cancel out. This will be, let me rearrange it. That will be far more better. This is
Sir,
68 into 5 into
4 will
100
be
by 4.
cancelled out by 17.
That's far better. Just cancel out it by 17 times, right? So this will be 117 to 5. Am I right?
Yes, sir. 850.
So this will be 850 and 1G. Understood? Interesting question. Next one is find the simple interest on principal amount 3000 at rate 6 and 1 by 4% per annum. Let me write it as small p because capital P is different for me. Per annum. So this will be how much? 6 into 4, 25 by 4, I think. 25 by 4% per annum. Per annum again. It must be small p. And the interesting point in the question is we have to calculate the amount from 4th of Feb 2009 to 18th of April 2009. So in this case, time is not given in years or months. It is given from one date to another date. So in this question, you have to calculate the number of days and then we will convert it into years and then we will apply the formula. So let's calculate the total number of days for which money is taken. So time will be from 4th Feb to 18th April 2009. How many days will be this? Uh, this will be, if it's 4th Feb, there are total 28 days in Feb. So this will be 24 days for February. Yes, 24 days for February plus complete March, and complete March will have 31 days, and 18th April means first 18 days of April, so this will be 18. So these are the days, and overall days will be 73. Now we have to convert it into years. So 73 days, 1 year and 365 days, so this will be years. Am I right? Now we can apply the formula for simple interest, and this will be P into R into T divided by 1000. Let's calculate what is the value of P. This is 3000 divided by 100. What is the value of R? 25 by 4. What is the value of T? 73 by 365. Now you have to calculate it. I'm not going to calculate it. Calculate it by yourself. Understood or any doubt? Yes or any doubt? Okay. Another question is a sum at interest is 13.5% per annum amount to rupees 4502.50 after 4 years. Find the sum. Sum. Find the sum means find the initial amount that is given on the interest. So in this, P, that is principal amount, is also known as sum sometimes. Now, what will be the value of sum? I do not know. So let's say principal amount is taken as X. According to the question, what will be the interest on this amount in 4 years? This will be P into R into T by 100. So P is X, interest rate is 13 and half. 13 and half will be how much? This will be 27 by 2 into time period is 4 years and divided by 100. So if you will solve it, simple interest will be, this will be I think kitna? So this will be 27x by 50. Am I right? Yes. Now according to question,
Yes, sir.
it states that a sum at this rate amount to this one, which means when you will return the money to the person from which we have taken it, we have to pay the original amount, the principal amount, and we have to pay the interest, and the overall cost is coming to be this amount. So according to question, we can state that principal amount plus simple interest cost us cost us 2502.50. And from here we have to find out x. So if I rearrange it, this will be 50x plus 27x divided by 50 is equals to 2502.50, and this will be how much? 77x will be 50 into 2502.50, and finally we will have the value of x, that is 50 into 2502.50 divided by 76. Yes, you be able to solve it? Any doubt?
No,
No,
sir.
sir.
Let's do some questions related to compound interest. Okay, question is, after 3 years, how much compound interest? So time is 3 years. How much compound interest will be obtained on principal amount rupees 7800 at the interest rate of 5% per annum? 5% per annum. So what will be the compound interest? So we know that compound interest I compounded annually is given by A, which is P into 1 plus R by 100 raised to power N, where N is the time period. So according to the question, principal amount is 7800 into 1 plus the value of interest rate is 5 by 100 raised to power N, that is for 3 years. Yes. So this will be 7800 into this will be 20, 1 by 20 plus 1 will be 21 by 20 raised to power 3. Now again we have to calculate it. This is the overall amount. So A will be equals to 7800 into 21 into 21 into 21 divided by 20 into 20 into 20. Just simplify it. If you will simplify it, this will be 9029.475 rupees. Now we are interested in compound interest. So compound interest will be overall amount we are taking minus principal amount. So overall amount which we are taking is 9029.475 minus principal amount is 7800. So this will be 1229.475. Understood? Are you getting it?
Sir, this formula for overall amount.
Yes.
Okay, sir.
Which formula?
Sir, this formula for overall amount,
Yes. This
not
formula
for
is for overall
compound
amount.
amount.
We can write it as we can write it as principal amount plus interest amount. This is A, right? Principal amount plus compounded interest amount is equals to A. And if you want to have interest, you have to take A minus 2. Understood? Next question is, find the compound interest on the amount 8,000 compounded at 50% interest rate for time period 2 years and 4 months. So this will be 2 years and 4 months means 4 by 12 year. That is 2 and 1 by 3 years. So in this case, time period is in fraction. So to calculate A, we have to use different formula, which is P into 1 plus R by 100 keep power 2 and 1 plus 1 by 3 R by 100. Am I right? So this will be 8,000 into 1 plus R is 15%. I think, yes. Divided by 100 raised to power 2 in bracket 1 plus 1 by 3 into 15 divided by 100. Simplify it. So this will be how much? If you will solve it, this will be 20. So this will be 8,000 in bracket 23 by 20 raised to power 2. And in this case, this will be 21 by 20. Understood? So A will be 8,000. 23 into 23 will be 529 into 21 divided by 202020. So 101010 will cancel out. 248 will cancel out. So we will have A equals to 23 into 23 into 21, which is 11109. Now compounded interest CI is given by overall taken amount minus principal amount. So taken amount of 11109 minus principal amount is 8,000. So overall interest taken on this money is 3109. Understood or any doubt? Yes, any doubt?
No, sir.
Okay. Next question is find the compound. It is straightforward question. Find the compound interest on principal amount this much at the rate of 20% per annum for 9 months, and it is compounded quarterly. Compounded quarterly. So how will you solve it? Principal amount is given to us, interest rate is given to us, time is 9 months. So in 9 months, compounded quarterly means you have to take interest to R by 4. That will be 20 by 4. Nine months will be divided into 3 quarters. 3 plus 3 plus 3. There is something wrong. Okay. So what will be the value for n in this case? We are having 3 plus 3 plus 3, 9 as 3 quarters, we are calling it as. 3 quarters means we will take interest at every third month. So formula will be A equals to P in bracket 1 plus r by 4 by 100 raised to power n. So this will be 16000. 1 plus r by 4 is 5 divided by 100 raised to power 3. 16000 into 21 by 20. 21 by 20, 21 by 20. So this will cancel out. 2 to the 4 to the 8 to the 16. We will have 2 into 21 whole cube. And if you solve it, this will give us 18522. So compounded interest will be overall amount minus principal amount. So overall amount is 18522 minus principal amount is 1600. Sorry, 000. 2522. Understood or any doubt? Understood? Okay, now I
Yes,
send
sir.
you PDF. Download it. क्या डेट है आज? 11 अप्रैल है. 2025. नहीं यहाँ तो नहीं हुआ, दिखते नहीं आज का. ओ हो गया बस. ये पीडीएफ भेज दो.
क्या बच्चों का स्कूल ऐड करने के सर्टिफिकेट है क्या?
नहीं ना, ये रखा था नहीं, पता नहीं. ये पता नहीं इतनी लापरवाही क्यों करते, चीजों को ऐसे ही डाल देते. ये पैसे का नहीं आया होगा, बताओ. ये संभाल के रखो, इन फ्यूचर कहीं ना कहीं काम आ ही जाएगा, बोर्ड लगाने का. कोई कुछ भी करते हैं लोग, कुछ नहीं समझता इनका. हाँ. भाई ये समझ गए ना आप लोगों को कैसे करना है?
यस सर.
ओके, क्वेश्चंस की प्रैक्टिस कर लेना, पीडीएफ ये डाउनलोड कर लेंगे, ठीक है. क्वेश्चन बैंक मिला क्या तुम लोगों को?
Yes, sir. Yes, sir. Yes, sir.
उसमें क्वेश्चंस मिक्सअप है, तो थोड़ा तुम्हें सेलेक्टिव होके देखना पड़ेगा, ठीक है ना. और भेजता मेरे पास, और कलेक्शन है वो भी भेजता. ओके, मंडे को होगा ना अभी? ये डाउनलोड कर लिया ना, मैं बंद कर दूं, ये क्लोज कर दूं मीटिंग.
Yes, sir. Yes, sir.